right. Today is the 5th. The 5th day of the 12th month. T-minus 20 days until Christmas. 20 days until Christmas.
11. I counted.
11 school days?
Yeah.
Nice.
Oh, I counted on my calendar. I got you. 11 school days left. So 10 and 8.
So I'm trying to give you lots and lots of possible ways this year to graph lines. It's kind of my responsibility as your algebra teacher is to teach you slope intercept. And then I taught you how to turn standard form into slope intercept. And then today's lesson is actually nice. This is a quick little one-day thing. It's a wonderful way to make graphs. Honestly, it's not always completely practical. Like it serves kind of a nice purpose when it works, and when it doesn't work, then it's kind of a road that we really don't want to go down. But I wanted to show you this today. So we're going to be using X and Y intercepts to make quick graphs. So let's say that we have it. We'll just sketch this in our notes. So we have a little X-axis and we have a little Y-axis, and we want to make a graph of this function. So after today, you'll have a nice new tactic. It's way quicker than converting it over into slope intercept. And I say sometimes the results are good and desirable, and sometimes they're not. So you just learn. You're all very bright people. You kind of learn when is a good time to use this technique and when is it not a good time to use this technique. So I'm going to plot some points. And I realize that this part of the lesson invariably is always confusing, but I'm going to do it anyways because it's where your learning needs to be. So I'm going to graph a bunch of points right here. And all of those red points have something in common. They're all on the x-axis. Can you tell me something mathematically true about all of the red points?
All their X's.
You guys decide which one of those you think. I agree. So that I was happy to let that take as long as it needed to take. It can take 30 seconds. It can take 2 or 3 minutes, but let's all get to that point. Let's all have that same conclusion that to be one of the red points, you have one thing about yourself that has to be true, and that is that to be a red point, any of those red points, your y coordinate has got to equal 0. If your y coordinate is 0, then you never leave the x-axis. And I couldn't tell you what the coordinates of any of the red points are because there's no scale, there's no grid, there's no marking. So I don't have any idea. And then I did that on purpose. I don't want to know what their x coordinates are. But I do know for sure that every one of the red dots has a y coordinate of 0. So for our notes, we can say this, that to be on the x-axis, your y coordinate has to be 0. So when y equals 0, you're finding what we call an x-intercept. And you can already see the writing on the wall. I mean, we're humans and we're going to get this backwards because if I'm on the x-axis, I'm going to want to say that x is 0. But that's that conversation that you guys had over there is key. You have to think your way through this and say, if I'm going to be on the x-axis, I never go up or down, which makes my other coordinate, my y coordinate, be the 0. Okay? And now I'm going to graph a bunch of blue dots. And again, the idea is I don't know where those points necessarily like numerically are. I don't know specifically what their exact coordinates are. But I can say one thing for certain about every single one of them. And what is it? So all of their x coordinates have to equal 0. Every one of those blue dots is what we call a y-intercept. If you're on the y-axis, then you, by definition, are what we call a y-intercept. If you're on the x-axis, you're an x-intercept. So far, so okay? Make sense? Okay, so you might be wondering, well, like, where are you going with this, Mr. Ahern? Like, cut to the chase. What's with all the nonsense? That understanding is what's going to enable us to make a graph I was clicking through some of these last night, just playing around, and I was timing myself. You can do them in under 10 seconds each. And if I asked you to graph this equation right now, it would not be done in under 10 seconds because you'd have to probably maybe move the 2y, move the 12, divide by 2, get your y equals mx plus b. This isn't going to be like that today. So this will be nice, and I think you'll enjoy the simplicity of this. So let's get to it. So considering the equation that I have up there on the board, I have it written in white. I have 3x minus 2y equals 12. Tell me if you agree with this statement. If I give you 2 points on a line, you can graph the line. I agree. We like more than 2. We like 3, 4, but can I graph a line with 2? Yes. And so what this knowledge today is going to enable us to do is to be able to find 2 points quickly, connect them, move on to the next problem. So here it goes. When I look at that white equation right there, if I told you to find me the x-intercept, look up carefully on the board. I've got this color-coded as best I know how for you. If we were going to find the x-intercept, what might we want to do? Nope. Look in this box. If I want to find the x-intercept, what might I do? Nope. If I want to find the x-intercept, what might I do? You're going to need to be more specific than that. Okay. Give me more. I like this. No dots, not yet. A little bit of math we got to do, just a little. The answer is in the red box. If I want to find the x-intercept, what should I do?
Oh, you add 2.
Nope. If I want to find the x-intercept, what would I do? It's in the red box. I already know what y is. If I want to find the x-intercept, what would I do? Ah! If that's not the best thing I hear all day, I don't know what it will be. And I'm going to say it again, just because if anyone's watching the recording, they're not going to hear you. What did you say again? Make y 0. Force the issue. You tell the math gods, I'm going in and I'm going to find an x-intercept. And according to all these red dots and this thing that I understand about the first 5 minutes of this lesson, if I want to find an x-intercept, then I have to, here it goes, what Zane said, make y 0. So I just go into this equation and I make that y a 0. I force the issue. If I make the y become a 0, what would the equation now say? What would the white equation say if y becomes 0? It would be that. You essentially eliminate the y term. If y becomes 0, what is 2 times 0? So what's the point of writing 3x minus 0? There isn't one. So I just write 3x equals 12. Divide that by 3. What do you get for x? Good. So we can say that the x-intercept of this graph is at the point 4, 0. If I wanted to find a y-intercept, the answer is in the blue box. What would I do? I would make x 0. I would force the issue, and I would say, x, your services are no longer needed. Because if I make you a 0, what's 3 times 0? And what would that equation now say? It would say negative 2y equals 12. And if I divide both sides by negative 2, what is y? Therefore, the y-intercept is at the point 0, -6. So I'm going to use green and yellow since I vandalized my graph over here. So you can see my green and yellow marks. The green dot is very simply placed on the x-axis to the right 4 units. So I'll go right 4. And I'm just guessing where 4 is. I don't have any idea. And where am I going to place my y-intercept? Down 6. So I'm going to go down what I assume is 6. And then I'm going to make a line. And that is that. And that's how, I know that that might not have felt very quick to you, but as you know about math, the first one is never quick because I've got a job to do, and that is to try to make you understand what's going on. But eventually this happens very quickly. So again, to find the y, what did we do? Yes, and to find the x, what did we do? Yes. Let's go again so you can see how much quicker this actually is. All right. So let's do an equation like this. -x plus 4y equals 8. I'm going to make some axes over here. And again, I'm not worried about the scaling of this. Don't worry about that. Well, I'll show you that the delta math will take care of this for you. So if I want to find the x-intercept, what do I do? Make the y 0. Remember, you've got a crisscross. To be on the x, your y is 0. To be on the y, your x is 0. So if we're finding the x-intercept and y becomes 0, what would this equation now say? So x equals, good. So I simply go on the x-axis and I head across to the left to -8, and I pop a dot there. Easy. If I want to find the y-intercept, what do I do? Make the x 0. What would the equation say? So what's y? So I simply go up on the y-axis to 2, pop a dot there, boop, and then make a line. And that, as they say, is that. Are you super lost? We, having taught this lesson for a long time, we used to call it the cover-up method. And I'll show you why. So here's another example, and we can do this in a way less mathematical way. So take a look at something like this. So you'll see what I mean by calling it the cover-up method. So right now, if I want to find the x-intercept, what do I do? So we're going to do this without showing any work, which is, I know, a little odd for this guy, but no work at all. Take your finger right now, and on your notes, because you just wrote this down, cover up the -8y. Just cover it up. Because that's effectively what happens when you make y 0, right? It's like it's not there. Are you reading the equation now? 4x equals 24. In your mind, divide by 4, what's x? Good. So we can very quickly, very simply, and I mean very simply, just go to the right 6 units and make a dot. So you just go, boop, make a dot at 6. Now we're going to use the cover up on the x because we want to find the y. Remember, find y, cover x. Find x, cover y. Take your finger right now and cover up the 4x and just look at the equation that you see. Solve it in your head. What's y? So you simply go down to -3, boop, put a dot, make a line, game over. Got it? Let's take a look. I want to show you that sometimes you're going to get fractions, okay? So just, I'll head over to Delta Math here in just a second to show you what it's going to look like. Sometimes things don't work out as we wish they did. So let's say we had 6x minus 2y equals 10. And this is, to me, where this method starts to feel like it has a little bit of a drawback. All the problems we've done so far, it's a no-brainer, man. Do it this way. It's quick. It's perfect. let's find the x. So cover up the y. Go ahead. Look at the equation that you get. You get 6x equals 10, right? Divide both sides by 6. What's x? 5/3, right? And it's 10 divided by 6, but good on you. Reduce that dumb thing so we get 5/3. And I'm not going to ask you rhetorical questions. The issue with that is that obviously that's a tweener, isn't it? And so what's going to help me here if I'm using this method today, which I am, is to write that as a mixed number. And since you're in high school, you should know that 5/3 goes one time fully with 2/3 left over, right? 5 divided by 3 is 1, 2/3 left over. So when you go to graph this, you would simply have to estimate on your graph 1 and then go a little bit past halfway to 2, because 2/3 is a little bit bigger than a half. So you'd go 1 and a little bit past halfway and place a dot. So that's going to be an issue that you'll encounter today, but that's okay. I know from clicking through a bunch that Delta Math is pretty forgiving. As long as you're in a pretty close ballpark, it's going to give you, because it can't expect you to know exactly where 2/3 is, right? But it can expect you to know that it's more than halfway between 1 and 2, right? The y-intercept on this one is nice. Cover up the x, and you get negative 2y equals 10. So what's my y-intercept? Right, so you'd have no issues there. So let me click over here real quick and just show you what this is going to look like. I hope that's my, do I not have a, oh, there he is. So this is what you'll be faced with here. And let me zoom in as much as I can. I got to try to leave a bunch of stuff on the screen. So there's the equation you see. And you're going to do this today fast. And I don't expect you to be showing work on something like this at all. You can if you want to. But let's find the x-intercept. Get rid of the y. What would the x-intercept be? Good for you. It would say 3x equals 21.
Oh.
Right? If you cover up the y, 3x equals 21, x is 7. So I'm going to grab this red dot and I'm simply going to pull it over to 7. Now, cover up the x. You get 7y equals 21. What's y? So I just drag the blue dot down to 3, click submit. That's that. All right, let me click through and see if I can find one that's, let's do this one. I like this one. It says x minus y equals 7. So cover up the y. What would the equation say? X equals 7. Boom, done. That was easy. Cover up the x. Y equals negative 7. Because it would say negative y equals 7, you got to divide by negative 1. So you pull this down to negative 7. Click submit. Slick and easy. Let's try to find a fraction here. Nope. You can see there's going to be a lot of whole numbers today. Here's a fraction. So it's okay. We're tough. We can handle this. So I'm going to show a little bit of work on this one just in case anyone's feeling a little woozy. Let's cover up the y first. What would the equation say? Very good. And then you can see what's coming, right, is if you divide by 5, it ain't going to work nice. But that's okay. I'm going to get x equals 28/5. 28/5 is vexing. You're like, how do you expect me to put a dot at 28/5? It's okay. What's 28 divided by 5? It is 5 with 3/5 left over. So it gets a little bit odd here that I've got to try to figure out what that means. And so I'm going to grab the dot, and I don't want to go like there. And I know that's hard for you to see probably, but you're in high school. You should know that 3/5 is more than half. And I've got my dot slid a little bit too far to the left here. So I'm just going to kind of estimate and go past halfway because 3/5 is past halfway. So that's what 5 3/5 would look like. What's the y going to be? 7y equals 28, y equals 4. So I'm going to drag it to there and hit submit. And it should be good. I say it'll give you credit as long as you're proportionally in the right ballpark. If you mark 3/5 at the halfway point, I hope it marks you wrong. If you mark 3/5 short of the halfway point, I really hope it marks you wrong. You need to understand how fractions look and feel when you're placing your dots. Yeah, you guys have any questions about how to do this? All right, I don't know how many I assigned, but you would imagine it's a lot because they're really, really quick. So get to it. It's assignment number 20, 30. I don't know what it is. 27 maybe. It should be assigned. If it's not, let me know.